All right, today we're moving on to section 6.4. We are going to use the AA similarity postulate. Thinking back to last semester when we talked about triangle congruence, what do you think AA might stand for? Angle, angle. So this time we are going to learn ways to prove that triangles are similar instead of congruent. So again, it'll feel a little familiar to us, but we are going to focus on similarity instead. Who was able to solve for x in number 1? Akira?
So you have to cross multiply, so 9x equals 972.
9x equals 972.
Then divide 9 from both sides, and x equals 108.
X equals 108. Anybody else agree? Get the same thing? We should. Seems good to me. All right, who was able to solve for x in number 2? Ari?
You have to set up a portion of a over 12 equals x over 15, and you get 120 equals 12x, and you divide by 12, and you get x equals 10.
Okay. I paused at your proportion. I'm not saying it's wrong, it's just not how I would have set it up, so I want to make sure it's an equivalent one. I believe it should still work out. So if I had been doing this, I would have set up 8 over x, matching up like one side from another triangle. But I think this one ends up being equivalent. So I would have set up 8 over x equals 12 over 15. But it would equal the same thing. So I'm fine with it either way. You could have had it set up a little differently even from that. So I would agree with the rest of what Ari said. 8 times 15. Divide by the 12. And Ari, I'm sorry, what did you say you got for x? What'd you get? 10? Okay, sorry. Just couldn't hear you. Okay, questions, concerns about that one? Again, multiple correct ways to set it up because you can write a proportion more than one way correctly. Need more time on our warm-ups. Okay. The angle similarity postulate states that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Remember, we cannot be confusing the idea of being similar with being congruent. Yes, those angles are congruent, but that does not mean that the triangles are. Just the angles. I don't care what the drawing looks like. Unless you can prove the triangle's congruent using one of the ways we learned last semester, we can't go there. We're only going for similarity this time. So on example 1, we are asked if the two triangles are similar. If so, write a similarity statement. Now, angle similarity postulate means that we need 2 pairs of congruent angles. How many pairs are marked right now that we know to be congruent? 1 pair. Which pair would that be? The right angles. So D and G have to be congruent because they're both right angles. That's not enough, though. We still would need another pair. 26 and 64 certainly are not congruent, but we could figure out the measure of angle E. How could we do that? Good. Add the 2 angles you know. Subtract that from 180. So 90 plus 26 gives us 116. We subtract the 116 from 180, and we would get 64. Now, do we need to go through and find angle K? No, because if this is 64, then that is our other pair of congruent angles. Angle K would end up being 26 degrees, but you don't have to do that. So, are the two triangles similar? Yes, they are. We need to write a similarity statement. Remember, when we write a similarity statement, you can name the first triangle however you want. So how do you want to name the first one? CDE works for me. And when we name the second one, we have to be consistent. So angle C would match up with angle K from the second one. D matches up with G, and E matches up with H. So we knew absolutely nothing about any of the sides, but we were still able to show that these triangles are similar. Questions, concerns? Need more time? Thank you. Oh, she's not here. All right, we'll keep going. Are the two triangles similar? If so, write a similarity statement. All right, so whether you drew these separately or left them all together, how many pairs of congruent angles are obviously marked already? One pair, but we need two pairs. Did anybody come up with another pair? Kara? Q is congruent to Q by the reflexive property. Q is congruent to itself, and it occurs in both triangles. If you really need to draw those separately to see that, that's fine. If you can see it just by seeing that these triangles overlap each other at the top, that's fine. But they are similar because we did have two pairs of congruent angles. Therefore, we've got to make a similarity statement. How do you want to name your first triangle? Somebody a little louder. Why don't you go a little louder?
PQR.
Okay, PQR. That's the little one. So if PQR is how we named the little one, the big one would have to be SQT. Good. Again, if it helps you to draw them separately to see that, that's fine. Do we have questions about example 2? Some people are flipping the page and seeing what's coming and getting super excited for notes today. Super excited. I can tell already. These ones aren't even going to be that bad. All right, but before we get to what we're really looking forward to, let's do example 3. Find the values of the variables. Couple things before we jump into the variables themselves. What do these little teeny tiny arrow triangle things mean? That we have parallel lines. In this case, I don't think we really need to use that. They kind of already did use it by the ones they marked congruent. Does anybody remember what that angle relationship would be? Alternate what? Alternate interior angles. We could use our other pair of alternate interior angles, or we could use the last pair of angles. How would I know that these are congruent? They're vertical angles. Okay, so I don't really care. You really just need 2 pairs of congruent angles. You don't have to mark all 3 of them, unless you really want to. So these triangles are similar. What I want you to be careful about is how you set up your proportions. So we know, of course, similar triangles have proportional sides. One of your ratios in your proportion, you better know both the top and the bottom. Anybody think they know one ratio you could fill in both the top and the bottom with numbers? 3/2. Good. Be careful the way that these are marked. So 3 and 2, for the way that I have labeled my diagram, are between 1 arc mark and no mark. Between 1 arc and no arc. We see that? Okay, we couldn't use 3 over x because x is next to one with 2 arcs, 3 is not. You understanding what I'm getting at here? You got to make sure you're careful about how you match these up. All right, so 3 over 2, we know both of those. Give me another one you want to compare. Okay, we could do 5 over x. Could we do x over 5? No. Why not? Okay, so that would like mix match our ratios. It's not being consistent. For example, 3 came from my kind of top left triangle. 2 came from the bottom right one. So on the top here, we need to use the same triangle that the 3 came from. On the bottom, use the same triangle that the 2 came from. This is not the only correct ratio or proportion to set up, but it's one that'll work. 3x equals 10. X equals 10 thirds. You could say 3.3 repeating. You could say 3 and 1/3 if you really wanted to. I would accept any of those. I would not accept not equal to 3.3. Not the same thing. I'm not taking it. If it's a repeating decimal, you better tell me that. Most of you have been good about that. Questions about finding x. Still got to find y. We can, again, still use the 3 over 2. This time, what would our other ratio be? 7 over y. Again, not the only correct way to set it up, but it's a good one. 3y equals 14. So y is equal to 14 thirds. That would be the same as 4 and 2/3. That would be the same as 4.6 repeating. Again, I would take any of those. I would not take 4.6, would not take 4.7, would not take 4.67. Okay, so don't be rounding at any time. Questions, concerns? Need more time? Okay, pause for a moment. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby, who is 5 feet 4 inches tall, casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Can anybody foresee the biggest hurdle we have to face first in this problem? Kara? Okay, our units. So we could translate everything into inches. Technically on this one, if you wanted to translate it into feet, you can. I like the idea of using inches, so that way we're not dealing with decimals until the very end. So we are going to have 2 triangles here. Of course, we're assuming that our flagpole is straight up and down. Oh, that's not straight up and down. We're going to assume our flagpole did not get, like run into by a car or something that would make it slanty. So if this is my flagpole, right now I know that it's 50 feet tall. Oh, nope, sorry. The shadow is 50 feet long. Other way. 50 feet long for the shadow. We don't know how tall it is. Next to that, we've got our lady, who is, again, we're assuming standing up straight, 5 feet 4 inches. I'll leave it that way for now. We're about to convert everything. This shadow is 40 inches. Are we all okay with this setup? Okay. So we do know that these are going to be similar triangles. Again, assuming our lady and the flagpole are both standing straight up, those would be 90-degree angles. If they're right next to each other, the angle of the sun should be the same as well. We have any questions about why these are similar triangles? Okay, let's go ahead and do the work to make everything be in inches. 5 feet is how many inches? 60. So the lady is how many inches tall total? 64 inches. If you want to just put that next to the 5 feet 4 inches, that's fine. Okay, if 5 feet is 60 inches, 50 feet would be 600 inches. So instead of using 50 feet, we'll use 600 inches. In the end, we are going to translate this back to being in feet. But for now, it's easier if we do it all in inches. If you really wanted to, you could have translated everything into feet. You just would have had decimals or fractions to deal with. If you did it correctly, I'd be fine with it. So we need to set up a proportion. Who can tell me what they want in their first ratio? X over what? Not saying that it's going to be wrong, but I like to compare one triangle to the other. Okay, so you could technically do X over 600 and have it come out correctly. I like to go one triangle to the next. Personal preference. Which means that my other ratio would have to be 600 over 40. Again, multiple correct proportions. As long as you end up multiplying the X times the 40 and the 64 by the 600, you have set up a correct proportion. 40x equals 64 times 600. If you have a calculator, that makes this a little easier. Since I don't, I'm going to do a little bit of canceling here. 4 goes into 60 15 times. So I need to take 64 times 15. What do we get? Okay, either way you do it, any way you do it, you should get 960. Questions, concerns about the 960? What are my units right now? What do I want my units to be? So I need to take the 960 and do what? Divide by 12, and what do we get there? 80?
Yeah.
So our flagpole is 80 feet tall. On this last quiz, I didn't get super picky about units on a couple of the problems. I think I marked it. On a test, though, you better be putting units in a word problem like that. Questions, concerns about example 4? Are we ready for the best part of our whole day? No? These aren't going to be so bad. We practically did these in the examples. We talked about all of our properties and things like that. We got some not givens. We've got some statements. We'll start with our givens. And we're going to give some reasons over here. Okay, we're given the diagram that isn't super helpful. If you want to mark or write out what sort of things are marked in your diagram, you can. What sort of things are marked in the diagram? Okay, we've got parallel lines marked. So I'm not going to ask you to then tell me that those are parallel. If you want to state that here, you can. You could tell me that EG is parallel to HJ, but you are not required to do that. You're also not required to do it later on and say diagram. We were given the diagram. What else do we know from the diagram? What kind of angles do we have in the middle? Vertical angles. So again, you could put that up here that you've got some vertical angles. You don't have to do that, but that's what it means to be given a diagram. All of those things don't have to be listed out again, or at all. Okay, so based on what they gave us from that diagram, what is a statement we could make? Kara?
Angle EFG is congruent to angle
EFG is congruent to angle, did you say HFJ? Works for me. How did Kara know that? Vertical angles are congruent. You could just put vertical angles, that's fine. Vertical angles will always be congruent to each other. We can mark it in our diagram now that we have made that statement with a reason. We're trying to show or prove that these triangles are similar. We've got one pair of angles congruent. We just need one more pair. Caitlin? Sure. Which ones do you want to use? Good. Angle FHJ, so that's the angle in the top right corner, is congruent to FGE by alternate interior angles. Of course, anytime you see parallel lines, you should be looking for those angle relationships. Alternate interior angles are congruent. Now that we've shown that we have two pairs of congruent angles, what are we ready for? The prove statement. So now we have enough information to say that triangle EFG is similar to triangle JFH. Our reason for that would be? Just angle. I like angle similarity just so I remember I'm doing similarity, not congruence. That'll be more important in the next couple lessons that we have that little similarity mark. Questions? Concerns? First proof of the semester, not so bad. 4 whole steps. Need more time? Ready to get the last one? Okay, again, in my opinion, this one is not so bad. We've got more parallel lines. Now, on this one, do you think we're going to be using alternate interior angles again? No, because we don't have lines like crisscrossing like we did on the last one. Anybody know what types of angles we should be looking out for on this one? If you're not sure, we'll get there in a minute. Again, we're given the diagram, which means that we don't need to list out the fact that we have parallel lines. We can just say, that's marked in the diagram, that's what was given to us. Because of those parallel lines, we do have some angle relationships. Now, this is much harder for you to do on your paper than it is for me to do on the screen. So I'm just going to temporarily erase, to the best of my ability, the segments that have the 2 arrows on it. So we can just focus on these ones that only have 1 arrow each. So based on the diagram on the board right now, what's left if I ignore those other 2 segments? Can we see what angle relationship we're looking at now? Okay. I'm not sure I've heard it, and if I have, it hasn't been very loud. So remember that technically there do exist these lines here in our triangles. So we don't want to talk about this big angle here. Caleb, you got a thought for us?
ACB is congruent to CED.
Angle ACB congruent to which one?
CED.
CED. I'm going to agree with that. Caleb, do you have the reason for that?
No.
Okay. So Caleb's got us halfway there. We're talking about these angles that are still part of our triangles.
Corresponding angles.
Very good. Those happen to be corresponding angles. Therefore, they are congruent because of our parallel lines. Questions about why it had to be those angles and why we are saying they're corresponding. Corresponding angles are congruent. Okay. Let's bring back the rest of that diagram. Now that we've brought it back, can anybody tell me another pair of angles, John?
CAB is congruent to ECD.
Good. Angle CAB would be congruent to angle ECD. So these angles down in the left corners. John, did you have the reason for that?
Corresponding angles.
Very good. Same reason. Corresponding angles. They're just corresponding on the other set of parallel lines. Now that we have two pairs of congruent angles, we are ready to make our prove statement. Those triangles are similar. What would our reason be? Yep, the whole thing we've been focusing on today, angle similarity. See, proofs aren't so bad. 4 steppers. Questions, concerns? Any more time looking at this? Okay. Your homework is, of course, not and a worksheet, just the book work. It should be on your assignment guide. And you should be working on your project, is what it should say. Not and worksheet, and project.